I'm using a new type of mate here that I've never used before. It's called a limit mate. So it basically constrains the movement of a part within an assembly with a maximum and minimum distance between two reference points. But what I come to realize during this design process is that I have a lot of interferences on the lower control arm and I need to redesign it. This isn't like a drift car where you need 45 or 60 degrees of steering angle. I think for an off-road and rock crawling application, getting as close as possible to 30 degrees is going to be just fine. And it ended up being better having the shocks straddle the axle because it allows the bolts to insert into the assembly from the outside, which reduces the number of cuts that I need to make on the lower control arm, which makes it stronger. I mean, spring rate can be basically whatever you need it to be. I think just by virtue of the fact that this part is gigantic, it looks small in relation to everything else, but it's still going to be plenty of meat, plenty of aluminum to have the strength that I need. The great thing about this design is that it uses rod ends as pivot points on the inboard side and spherical bearing on the outboard side. And the reason for that is if you want camber and caster adjustment, you can do that by threading in and out those rod ends, which it'll adjust the alignment of the wheel with respect to the chassis. In fact, one of the Can-Am Maverick Rs just won the King of the Hammers Ultra 4 race. And it didn't just win the UTV class, it won the whole event. Now that the profile and the envelope is set, now I can just design the internal features to capture the hardware and make sure all those clearances are where I need them. So the constraint on the steering is defined by the misalignment spacer on the spherical bearing. So if I have a 25-degree maximum misalignment on the spherical bearing, that sets my angle for steering. SOLIDWORKS was a little bit confused by the spherical bearing placement that I have because they're at strange angles with respect to each other. I just need 3 points of contact to constrain the part in space. And I need to make some clearances here for the spherical bearing hardware. This is my favorite part of the process because it makes the part look done, which is exciting. It also disincentivizes you from overworking it and making the part more complicated than it needs to be.